our Part C, overview of web programming. Before we look at the web programming part, I like to give you a little background about IP addresses, because later, so when we talk about client-server communications, we need to use this IP address concept. All right, so the part C.1, networking basics, IP addresses. I mentioned IP address concept before, but in this video, we try to study a little more background, but still we keep the basic part. Yeah. All right. Ipv4 and Ipv6, these two versions. Yeah. The first version, the old version, yeah. The reason we need to introduce the newer version, Ipv6, because we run out of the resources. Yeah. All right, so first, let's look at the Ipv4 first. Yeah. So we use this client-server communication model here. Now, we know in order to locate one device on the internet, we need to assign an IP address to that device, no matter that device is at the client side and the server side. Yeah. So one IP address is needed to identify one machine on the internet. Yeah. All right. Let's look at the Ipv4 first. Yeah. All right. So Ipv4, I use the telephone number to, try to help you understand the reason we want to write that IP address in a special format. Because we sometimes, if we want to memorize the IP address, we want to make it as easy as possible, right? Yeah. So here, written in human readable notations. Here you can see the designer, they try to make the notation human readable, like telephone numbers, human readable, right? Yeah. But still not that easy to memorize for an ordinary person. Yeah. Here, so let's look at a concrete example. This is one typical IP address example. Yeah. So you can see from the structure, you see four decimal numbers separated by dots. Okay, separated. Yeah. That's the basic structure of Ipv4 address. Yeah. Here we call it dot decimal notation. Dot decimal notation here, okay, to make it more human readable. Think about if we remove the three dots, how many people can memorize one IP address number, right? Too hard. But if you put three dots, so you divide the whole IP address into four different decimal numbers, then it becomes a little easier to memorize. Yeah. All right. Here, here you can see each decimal number because we use 8 bits. 8 bits. Yeah. Because total 32 bits. So each decimal number 8 bits. So the range of each decimal number must be between 0 and 225 inclusive. Okay. So that's the basic knowledge. Yeah. Then with that number of Ipv4 addresses, how many? So here I want to go back to the previous video. I give you approximate number. How many? Right? How many Ipv4 addresses, right? Yeah, approximately, yeah, 4.2 billion, right? Yeah, 4.2 billions, right? Yeah, approximately. Yeah, we know we need, for the whole world, we need much more than that. Now, 4.2 billion IPv4 addresses, not enough, yeah, for the current society. Yeah. All right. Among those 4.2 billion IP addresses, there are several different categories. The first category, so we call private networks. Private networks. Yeah. So what's that? Private networks, right? Yeah. So it's very easy. We know each company, even each home, you can create your home network, right? Company. So they have company-wide network. So that's the private network. Okay. Within each organization, they can create their own networks. So we call it private networks. Yeah. All right. Yeah. Many private networks. Then the internet will connect, all those private networks then to form public networks. The internet. So that one we call it public networks. Yeah. Everyone can access that public network. Yeah. So it's a public network. Now think about within a private network, do you need some special addresses to identify devices within private network, right? Yeah. So for that reason, we need to use private networks. The number approximately 18 millions. So that number, that many, okay? Another special type of usage for IP addresses, multicast addressing. Multicast addressing, broadcast, right? Multicast, yeah. A special usage. Yeah. For that reason, some special IP addresses should be allocated for that special purpose. How many? 270 millions. 270 millions for that special purpose. Yeah. All right. Yeah. So then the remaining IP addresses, two types, static IP addresses and dynamic IP addresses. From the names, you can see static, no change all the time. As soon as that IP address is assigned to one device, it never changes. Static, right? Yeah. Dynamic, it can change. Yeah. This period of time you use one IP address, but next period of time you may need to use a different IP address. That could happen. Yeah. So typically for servers, it is better to use static IP addresses, servers. Yeah. Because people always need to connect to the same IP address. Yeah, more convenient, right? If it changes, it's not very convenient. How do you connect to the same server, right? Yeah. But for client, the story is different. For clients, the story is much different. So why? We know for the client, the server never needs to talk to the client at the beginning of a communication cycle, right? So at the beginning of the communication cycle, it is always the client starts a communication. So then the client, they do not have to use static IP addresses. They can use dynamic IP addresses. Okay? Yeah. So their IP addresses can change, right? Can change. At this moment, the current IP address, they use that to connect to a remote server. So then the remote server just return the information, data, back to this client. So the server does not need to memorize the IP address of this particular client. Not necessary. Yeah. Whoever requests data service for that server, the server just return the data service back to the same client. Okay? Dynamic or static from this client, it doesn't matter. Okay? Yeah. So for that reason, the client machines can use dynamic IP addresses, and it's pretty common actually for most of the client machines. Dynamic IP addresses are used. Yeah. So the reason is very simple. So why is that? The reason is very simple because it can save resource. Yeah. So for the dynamic, it can save a lot of resource because many clients, they can share relatively small number of IP addresses, right? So when you sleep, when people, because when you use client machine, when people do not use that client machines, that the resource can, the internet service provider, here, usually the internet service provider, they do the assignment, IP address assignment. So they can assign the dynamic IP addresses to other users, right? So other users, when they request, internet connection, internet service, then that dynamic IP address can be assigned, things like that. Many users can share relatively small number of dynamic IP addresses. Yeah. All right, so that's the concept. Yeah. Then private IP addresses. Now, within each individual private network, then there are certain number of private IP addresses, not unique globally, because when you jump to a different private network, the same private IP address can be used in some different private network. No conflict. Why? Because each private network, they have a unique public IP address. Unique public IP address, right? Yeah. Each one has a unique public IP address. Then inside that network, so outside unique, right? Inside not necessarily unique, right? Inside the network, so one certain private, for example, actually this one is a typical private network IP address. Okay, 192.168.100.1. This is a typical private IP address. So in many homes, sometimes people look at their, own IP address, they see this IP address. Very common. So why I always see this one? So, for different places, always see this one because this is a private IP address. So not necessarily unique. Yeah. All right. So that's this concept. Private IP addresses, but unique within local network. So local inside this network, then each device uses unique private IP address. All right. So next one, public IP address. Here I mentioned a little bit. Then it must be unique globally, unique in the whole internet. It must be unique. No confusion. So it's very easy to locate that particular. Here could be a device, could be one private network using one public IP address. So that's the main IP addresses. So why we call main IP addresses? Here, let's try to estimate how many public IP addresses, that number, okay, public IP addresses. Yeah. So here, let me use P number, okay, public IP addresses. Okay. Remember the total IPv4 addresses 4.2 billion, right? Yeah. Here we use billion as the unit. Yeah. Second, let us remove 18 million private IP addresses, right? Because they have to be separated. Okay. So they have to be separated. Yeah. So minus 0.018. Use the billion as the unit. Yeah. So the million, 0.018 billion. Yeah. All right. Then multicast addresses 0.27 billion, right? Yeah. So that is 0.27 billion. Now you can see the answer, the number slightly less than 4 billion, right? 3.9 something billion, right? Yeah. We just estimate. Yeah. So you can see the total number of public IP addresses, you have approximately 3.9 something billions. That number, pretty big. Yeah. Although we know we need much more than that. Yeah. So next, we will look at IPv6, the relatively new version of IP addresses. Yeah. Here, because IPv6 much more complicated. So here, I need to explain the structure a little more, but I do not want to go too much deeper. Not necessary. We only need to know, the basic information. So we just get some basic impression on it. Yeah. All right. Here you see one typical IPv6 address. Yeah, the format, the structure. So you see here. Yeah, let me just explain a little more. So what's that? So an IPv6 address is made of 128 bits. Okay, so you have an idea how many total IPv6 addresses, right? Remember from the, what we learned from the previous video, one previous video, 3.4, approximately 3.4 multiply 10 to the 38th power, right? That big number, huge. Yeah. So we call it 340 on decillion. So that number on decillion. Yeah. All right. So anyway, so let's look at the description of one IPv6 address. Yeah. So divided into 8 16 bits blocks here. So 8, 1, 2, 3, 4, 5, 6, 7, 8. Each block 16-bit block. Okay. Yeah. All right. So then each block is then converted into 4-digit hexadecimal numbers. 4-digit hexadecimal. So you see 4 digits, right? But we use the hexadecimal, not decimal. It's a hexadecimal. Yeah. The basic knowledge about hexadecimal, I think you get from Math 3000, right? Yeah. Math 3000. You have the basic knowledge of hexadecimal. When you learn about the basic numeral systems, you should learn that, hexadecimal system. Yeah. All right. Here, let me just give you a simple example. So using that, the notation we call colon hexadecimal notation. IPv4 we call dot decimal notation. Here we call colon hexadecimal notation. Yeah. All right. But I hope you can easily convert each hexadecimal number to a decimal number. Yeah. So when I do review, so I may do one example. Yeah. If you do not, remember the details, I can show you one simple example. Yeah. Then, the basic idea, get yourself familiar with the hexadecimal numbers. Yeah. All right, so here, remember, we try to make it human readable, but for this version, it is extremely hard, right? Too long, so long, right? Yeah. So in order to simplify this long form a little bit, here I want to talk about 3 rules. We have here the first rule: discard leading zeros in each block. But that's for the non-zero block. Non-zero block. Yeah. For the zero blocks, we will have different rules. Yeah. So here, when we talk about non-zero blocks, so we use the rule number 1, discard leading zeros in each block. Yeah. So look at this example. Here, look at this 0, 0, 6, 3. It's a non-zero block, right? We discard leading 0, double 0. That leading double 0, so we discard it. So you will see, we only see 63 left. Okay, so that's the first rule. Yeah. The second rule, if 2 or more blocks contain consecutive zeros, 2 or more, right? 2 or more blocks contain consecutive zeros, omit them all and replace with double colon sign. Yeah. So what's that? Yeah. We try to make the form as compact as possible. Now, that's the purpose. So here you can see, because 2 consecutive blocks, all 0 blocks, so we reduce, okay? We use 1 double colon replace the whole portion consecutive 0 blocks. Yeah. So as a result, you see this double colon. Yeah. All right. That's the rule number 2. For rule number 3, consecutive blocks of zeros can be replaced only once by double colon. When you do that, you can only do it once. Why not twice? The reason is simple, because if you are allowed to do twice, people get confused, right? Location 1, location 2. How many blocks at location 1? How many 0 blocks at location 1? How many 0 blocks at location 2? Nobody can figure out, right? So in order to avoid that confusion, so we make this rule number 3. You can only do once, double colon, then no confusion, because people do some simple arithmetics. People can figure out how many 0 blocks for that double colon, right? Yeah, so that's the first. So the second part, so if there are still blocks of zeros in the address, they can be shrunk down to single 0. You still, the whole block shrunk to 1 0. Okay? You make it, but not nothing. You make it shorter, but still you need to use 1 0 for it. Yeah. All right, so here in our current example, you can see we have another 0 block, so we use 1 0 to replace that 0 block. Okay. Yeah, with these 3 rules, so you get some, basic understanding. Yeah. So we can make one IPv6 address as simple as possible. Yeah. But we will not go more than that. So that should be enough for us. Yeah. All right. So the last part, I want to talk about the structure a little bit. Structure of IPv6 address. Yeah. The first part, site prefix. Yeah. Because based on different usages, so we still we use different portion of bits for different purposes. Yeah. First, site prefix, we use the first up to 48 leftmost bits. Yeah. So this part, so what's the usage for that? So why use that? Yeah, from the name, site prefix, site, website, right? Site prefix. Yeah. So you can see that's the public topology of your network. Your network, each network should have a public IP address, right? Yeah. So here, public topology. Okay. In that global internet network, yeah, each network needs one public IP address. Yeah. So the first 48 bits, that part used for that purpose. Yeah. Okay, leftmost 48 bits. Yeah. Then the second part, subnet ID, 16 bits. 16 bits subnet. From the name, subnet, right? Within each individual private network, subnet. Okay, yeah. The internal topology. Inside each private network, so you use internal topology of the network to a router, right? Yeah. So you have a router, connect to outside world and internal network. Yeah. All right. So that's the part 2. Then part 3, interface ID, the rightmost 64 bits. The remaining bits, rightmost 64 bits for the interface ID. See? So you have, a lot of different interfaces. You can represent interface, okay? For different devices, right? Interface, yeah. All right, so you can see in this way, you have plenty of resource. So we make the, IP address resources with this new version. So we don't worry. So we should have a lot of time, people, mankind. So we have many years. We don't need to worry about run out of resources, right? Yeah, we have plenty of resources for a very long period of time. Yeah. All right, so let me stop our C.1 video right here.